Hello everyone, welcome to the Best Practice Series channel. This time we bring you a series of operational demonstration videos for the DNBSEQ-E25. Alright, let's move on to the first section, DNB preparation. Currently, the sequencing reagents launched on the DNBSEQ-E25 mainly include the FCL-SE100 and PE150 sequencing reagent sets, which are compatible with MGI libraries, as well as the FCL-SE100 and PE150 sequencing reagent sets, which are compatible with third-party libraries. Today, we will demonstrate the sequencing operation using the FCL-PE150 sequencing reagent set. First, let's take a look at the composition of the sequencing reagent sets. All sequencing reagent sets consist of two boxes: the sequencing reagent box and the sequencing flow cell box. Upon opening the sequencing reagent box, we can see the sequencing reagent cartridge, waste container, small funnel, and DNB preparation reagents. Upon opening the flow cell box, we can see a flow cell in a non-transparent packaging. After familiarizing with the sequencing reagent set, we can begin the process of preparing the reagents. The first step is the thawing of the sequencing reagent cartridge. Currently, two recommended methods are suggested. The first method is to take the sequencing reagent cartridge out of the box one day in advance, and let it thaw overnight in a refrigerator at 2 degrees Celsius to 8 degrees Celsius. The second method is thaw the sequencing reagent cartridge at room temperature on the same day in the laboratory environment. It is not recommended to use other methods of thawing. Meanwhile, we can simultaneously start preparing the DNB. The PE150 sequencing reagent set demonstrated is suitable for libraries with 300 to 500 base pair insert sizes. In the library prep workflow, we should know the library's total size and concentration. Use size and concentration information to calculate library input with the nanogram to femtomole conversion formula. For the demo, the library has a concentration of 20.1 nanogram per microliter and total size of 427 base pair. Using the formula, we need a library input of 0.56 microliter. Next, we can proceed with the preparation of the DNB. First, take out the low TE buffer and make DNB buffer from the sequencing reagent kit. Thaw, vortex to mix, centrifuge, and set aside on a rack for later use, following the instructions in the manual. Label a 0.2 ml PCR tube. Add 19.44 microliter of low TE buffer and 20 microliter of make DNB buffer to the PCR tube. Mix make DNB reaction mixture thoroughly by vortexing and centrifuge. Place the PCR tube in the thermocycler for primer hybridization. Meanwhile, take out make DNB enzyme mix 1 OS and make DNB enzyme mix 2 OS from the box. Vortex, centrifuge, and then place on ice for later use. After primer hybridization, remove the mixture from the thermocycler. Briefly centrifuge, and then add 40 microliter of make DNB enzyme mix 1 OS and 4 microliter of make DNB enzyme mix 2 OS. Vortex and centrifuge the mixture, then start rolling circle amplification in the thermocycler. After the reaction, remove the tube from the thermocycler and add 20 microliter of stop DNB reaction buffer. Using a wide-bore pipette tip, gently pipette 5 to 8 times to mix. Measure DNB concentration by mixing 2 microliter of DNB with the Qubit ssDNA assay kit in the Qubit fluorometer. The acceptable DNB concentration range is 4 to 40 nanogram per microliter. This demo's concentration is 22.6 nanogram per microliter. This ends the DNB preparation section of our demo video. Following DNB preparation, we'll now prepare the sequencing reagents. First, take out the signal protein buffer, DNB loading buffer 2, signal protein 1 and signal protein 2, and let them thaw on ice for 10 minutes. Meanwhile, take out the thawed sequencing reagent cartridge. Before opening the sealed packaging, check the integrity of the cartridge. Hold the cartridge on both sides. Invert it 20 times and tap it on the table 10 times. Invert 10 more times and tap again 10 times. Hold the middle of the bottom of the cartridge and flick it forcefully once. This step uses centrifugal force to settle reagents and remove air bubbles from the cartridge bottom. Next, open the cartridge's outer packaging and place it on the table. As per the manual, add 31.5 microliter of signal protein 1 and 21 microliter of signal protein 2 to the signal protein buffer to make the signal protein mixture. To prevent bubbles, gently mix the buffer without vigorous shaking. To mix the signal protein mixture thoroughly, secure the cover of the signal protein mixture and invert the tube 10 to 15 times. After mixing, use the funnel provided to add the signal protein mixture into the MSP well in one go. For FCL-SE100 or APSI FCL-SE100 sequencing, reagent preparation is complete with this step. For PE150 sequencing in this demo, we still need to prepare the MDA reagents required for PE sequencing. First, take out the MDAT reagent and the MDA enzyme mix. Invert the MDA enzyme mix to combine, then briefly centrifuge. Transfer 50 microliter of MDA enzyme mix into the MDAT reagent tube to create the MDA mixture. Invert 10-15 times for mixing, avoiding vigorous vortexing to prevent bubbles. Puncture the MDA well with a clean pipette tip. Add all the mixed MDA mixture into the MDA well, being careful to avoid bubble introduction. Remove the stoppers from wells 1, 2, and 3 with pointed tip tweezers. Then set the cartridge aside on the table for later use. This ends the sequencing reagent preparation section of our demo video. Welcome to the sequencing run setup and data export section. After preparing the sequencing cartridge, log into the DNBSEQ-E25 sequencing software. Click the central icon to access the sequencing interface. The reagent compartment will initialize, opening the door and ejecting the tray automatically. Click on the recipe drop-down list and select PE150. Select the corresponding barcode from the barcode drop-down list based on the library's barcode type. For an APSI library, create and import the barcode list beforehand. When ready, proceed to the next step. Scan the sequencing flow cell's QR code with the barcode scanner. The flow cell ID, throughput, and expiration date will autofill in the UI software. If scanning fails, manually enter the information from the label using the on-screen keyboard. Open the flow cell package, inspect the flow cell's integrity, and ensure the QR code matches the label's serial number. Align the valve's positioning hole with the loading frames post to install the flow cell. Remove the prepared sequencing cartridge and scan its QR code. The reagent cartridge ID, recipe, and expiration date will display automatically. If scanning fails, manually input the information using the on-screen keyboard. Remove the cartridge's bottom protective cover, ensuring all 21 rubber stoppers are intact. Align with the positioning post and place it onto the flow cell without shaking or inverting the cartridge. Ensure the waste container's rubber stopper is open. Place it on the tray and fasten it with the positioning clamp. Click Yes after installation, and the instrument will auto-load and press. We can see the cartridge and flow cell inserted and pressed by the sequencer. It is important to note that should not manually close the compartment door before the sequencing starts. The software will advance to the DNB ID screen, where you can enter or scan the DNB ID. Prepare the DNB loading mixture as instructed, and mix gently 8 times with a non-filter wide-bore pipette tip. Using a non-filter wide-bore pipette tip to add the DNB loading mixture to the flow cell's DNB loading well. Ensure no bubbles are present. Then click to proceed to the parameter review interface in the UI. Verify the sequencing parameters carefully. If correct, close the compartment door manually and click Run to start sequencing. On the sequencing page, monitor the progress bar for time remaining, or switch to view the estimated completion time. After the first cycle, the system auto-generates the first base report on the UI, displaying SNR, Q30, and more. After sequencing completes, The software will automatically display the report on the UI interface. Click Complete Post-Sequencing, and the sequencer will open the door and release the cartridge. Remove the flow cell, cartridge, and waste container, disposing of them as per local regulations in designated bins. To export sequencing data, insert a USB drive into the DNBSEQ-E25's USB port. Click History on the taskbar. Select the desired data, and click Export. That concludes our DNBSEQ-E25 operation demonstration. We hope it has guided you in using the DNBSEQ-E25. When you face any issues, don't hesitate to contact our technical support, or call our hotline at 4000688114. Visit our official website for more details. Thank you.